In this video, we are going to talk about graphing logarithmic equations. A logarithm is the inverse of an exponential function. Okay, so the parent function of a logarithm is f of x is equal to log of x. Now, again, if the base is not there, the base is 10. So what I'm going to do is I am going to show you how a logarithm is the inverse of an exponential. So if we start by figuring out the inverse of this. So your inverse of log base 10 of x is going to be 10 to the x. So if we were to graph this, if we were to graph 10 to the x, so when x is equal to 1, my graph is way up here at 10. When x is equal to 0, my graph is down here at 1. And so what this looks like is something like this. Okay, that is your function 10 to the x. Now, the inverse is whenever you switch your x's and y's. So right here we have the coordinate point of 0, 1. Well, the inverse of that is going to be the coordinate point 1, 0. If we were to switch the coordinate point of 1, 10, then we would have 10, 1. So what we have here is we have our logarithmic equation that looks like this. So if you notice, they actually mirror each other. So there is an invisible line here. Y equals x. That it is a reflection. That's what an inverse is. It's a reflection across the line y equals x. So to graph a logarithmic function, we actually use an exponential and then just switch our coordinate points. Let's look at an example. So we have f of x is equal to log base 2 of x. So again, we cannot graph it in the logarithmic form, so we go to an exponential. So the inverse of this is going to be 2 to the x. Well, if we make a table of values for 2 to the x, when x is negative 2, we are at 0.25. When x is negative 1, we are at 0.5. When x is 0, we are at 1, 1, 2, and 2, 4. To get the inverse, we just need to switch our x's and y's. So now we are going to have 0.25, negative 2, 0.5, negative 1, 1, 0, 2, 1, and 4, 2. This is your table for your logarithm. So we graph this. At 0.25, we are at negative 2, so right about there. At 0.5, we are at negative 1. At 1, we are at 0, 2, 1, and then 4, 2. This is our logarithmic graph. The domain. So the domain of an exponential function is going to be negative infinity to positive infinity. So if you find the inverse, then that means that your range is going to be from negative infinity to positive infinity, which makes sense because range is your y value, so we are going down all the way to negative infinity. And as we get further to the right in the x value, this graph will slowly increase and it will eventually go all the way up to positive infinity. That's why our range is from negative infinity to positive infinity. The domain, however, is a little bit different. The domain is your x values. Now, if you notice, my graph does not cross the y-axis. It does that for a reason. there is a vertical asymptote at x equals 0. So my domain is everything to the right of 0. So my domain is 0 to positive infinity. Now let's look at end behavior. This one, again, it's switched. It's just weird. So as x goes to blank, f of x is going to positive infinity. So we kind of have to think about this in the opposite direction. So where is my graph going to positive infinity? So if we continue up this way, we are going to positive infinity way over here. Well, that is whenever x goes to infinity. Now we need to figure out, as x goes to blank, f of x goes to negative infinity. So where does my graph drop off the face of the earth as we get close to what x value? As we get closer to this asymptote here, my graph will drop off the face of the earth. So as x goes to 0, f of x is going to negative infinity. Let's look at another example. We have f of x is equal to log base 1/3 of x. So if we graph the inverse, that would be 1/3 to the x. So if you were to make a table of values, at -2, you are at 9. At -1, you're at 3. 0, 1, 1, 0.3 repeating. And at 2, we are at 0.1 repeating. So to get the logarithmic, you flip your x's and y's. So now we have 9, -2, 3, -1, 1, 0, 0.3 repeating 1, and 0.1 repeating 2. So graph these values. At 9, we are at -2, which is right there. 3, we are at -1, 1, 0. 0.3, we are at 1, and even closer to that, we are at 2. So this is what my logarithmic graph is looking like. It's going to do something like that. Domain. Again, this graph, there's an invisible line or an asymptote along the y-axis. So we have an asymptote at, don't need a highlighter there, at x equals 0. So your domain is going to be from 0 to positive infinity. We stop at 0 here, but we keep going all the way to the right. Range for all logarithmic functions is going to be -infinity to positive infinity. And then end behavior. As x goes to blank, f of x is going to positive infinity. So where is my graph shooting upwards to positive infinity? Well, as we get closer to 0. Now, as x goes to blank, f of x is going to negative infinity. So where is my graph heading down towards negative infinity? Well, it's slowly creeping that way as we go further to the right. Well, further to the right is positive infinity in the x direction. So I know they're very weird to graph, but that is how you graph log functions.